1, 2, 3, passt. Yeah, thanks. Thanks for coming so early in the morning. So my first question would be, do you want me to do the talk in English or in German? English? Okay, all right. Okay, so first of all, just a little bit about me. So my name is Jochen Kressin. I'm the co-founder of FLORAGUN GmbH. We're the makers of SearchGuard, which is a security suite for Elasticsearch and the ELK stack. Company was founded in 2012, so we're located in Berlin, but yeah, it's already been told I'm originally from Franconia. And we have some partner offices in Seattle, New York, and Latin America as well. So first of all, a word of warning. Today in my talk, I'm of course talking about zero trusted networks. So the examples that I'm using are focused towards Elasticsearch. But you can actually exchange Elasticsearch with any other product like MongoDB or Kafka or whatever. So I'm just using it because as an example because I'm using it a lot in my day-to-day work. And the second one is that I'm not going to talk about deep technological stuff. It's more about concepts and a new way of thinking about network security. So why this topic? Well, excuse me. Well, first of all, I'm naturally talking a lot with customers about Elasticsearch. So we have a lot of customers storing very sensitive data. It's not only log data. So the ELK stack is typically used for log analytics, that's for sure. But we also have customers from the financial area, which store financial transaction data, from the healthcare sector, which store patient data, or any other personal identifiable information in Elasticsearch. And when they come to us, since we're offering a security solution, my first question would always be, so if you're storing sensitive information in your data lake, Elasticsearch in that case, and now you need some form of security, well, so what security measures did you have before? And the answers are obviously quite scary, because most of the time we hear that it's totally unprotected. So you probably heard about, data leaks regarding especially Elasticsearch, but also other technologies, and I have a few examples in a moment. But even the very large companies, and I'm talking about Fortune 500 companies or DAX 100 companies, sometimes say, well, we don't have any security in place for our sensitive data in our data lake. The second answer is, well, everything's fine because we're behind a firewall, and that's typically sufficient. So we keep the attackers at bay, and everything that's happening inside our network is inherently secure and trusted. And the third one is we have a VPN and a firewall, which is a little bit better, but basically it's the same. So people think that these setups or infrastructures or measures are sufficient to protect your data. So, and this is typically called perimeter security, which typically looks like that. So on the left-hand side, you have the evil internet with all the bad guys in it, and then you have your perimeter, which is secured, for example, by a firewall, VPN, some other network appliances, and then you have your data stored in your data lake. And the concept behind perimeter security is that on the left-hand side, everything's untrusted, and on the right-hand side, everything's trusted, which is your trusted perimeter. So this concept has a few assumptions. So the first assumption is that the traffic from the outside cannot be trusted. This is something that I would agree. Of course, there are bad guys out there trying to hack into your network and steal your data. Okay, that's for sure. But then already the second one, that the traffic inside the perimeter can be trusted, is flawed. This whole concept of perimeter security worked like 10 years ago or 15 years ago, but it doesn't work nowadays. So the third assumption is that the actual access to the perimeter can be fully controlled. So as a consequence, VPNs, firewalls, and stuff like that are sufficient to protect your data, at any point in time, you actually know who is inside your network and has and which access rights this person or this device has. Therefore, the traffic inside your VPN doesn't necessarily have to be encrypted. So what we're seeing a lot is that you have some, let's say, TLS encryption, but at some point inside a network, it's terminated and it's unencrypted. The concerns are, well, if I do end-to-end encryption, I get some performance penalty that I have to pay, and since we're inside the trusted parameter, I don't need to do that. And the last one is that the security breaches, if security breaches happen, can and will be detected. So these are the assumptions this is based on. So the main question here is, does parameter security still work? I mean, obviously it worked for some time, but is it sufficient nowadays? Because, because if it still works, why are we still seeing so many data breaches and data losses on a daily basis? And I just have a couple of examples that happened in the last couple of months. So there was this data breach at Exactis. It's a US company. So they lost 340 million of personal data, phone number, home address, number, age, gender, and stuff like that. And there was this quote, it seems like this database is this is a database with pretty much every US citizen in it. So it's quite a major breach. And I think there was even social security number in it. So why did this happen? Well, this was an example where an Elasticsearch installation was open to the public and didn't have any security measures installed. So that means, well, you could say the parameter was not secured at all, or you could also argue there was no parameter at all because everything was publicly available on the internet. Data breach at Apple, also very interesting. Apple lost many million of customer data from an internal database. Why did this happen? Well, they worked together with distributors, and these distributors had access to internal systems at Apple, including the customer database. And yeah, they just stole the data, sold it on the black market for a couple of $1 million, which means that Apple as a company granted a distributor access rights to some internal system, and they didn't control what this distributor did with the data. So this is a classic example of an attacker which is already inside your parameter. Best Western, also just a recent leak. Customer booking details have been leaked. And this was through a system called AutoClerk, which is used for hotel reservation or reservations in general. Again, name, date of birth, gone. Why? This was a cluster hosted on AWS, so here comes the cloud into the picture. And this one is interesting because AutoClerk is one platform which hosts multiple client data. So it was not only Best Western was affected, but many other companies as well, which raises a question in that case. So how do you define your parameter? So you have the service running in the cloud, you have multiple clients. So where's the parameter for each client? And last one is a cosmetics company. 6 million orders exposed, also including name, home address, phone number, and the one. And also even internal data from E4G, stored traffic, turnover, order volumes. This is pretty interesting because this data is very interesting also for competitors. So it's not only about getting some personal information from customers, stuff like that, and selling them on the black market or the dark web or whatever. But in this case, even internal KPIs of this company have been leaked. Again, this was an unsecured Elasticsearch setup, which was operated by, I didn't know this company, AliceNet. It's a consulting company in France, as far as I know. And they're actually consulting many companies, which raises the question, like they ask here, Other clients of them are also at risk, and they don't know if there are any other unsecured databases out there that haven't been discovered yet. So, and these are just like 4 examples from many that you see on a daily basis. So, oh, sorry, I have one more, and this is an interesting one. OneLogin, I think that was already last year, and this is especially interesting because it's a password and identity management platform. And as far as I know, they suffered data breaches twice. So this was the second one. Also very interesting, they are hosting on AWS, and they lost a key to AWS. So an attacker could not access the systems directly, but they could gain access from an intermediate host. Now, and this shows how critical that could be, because OneLogin had to tell all the customers that they need to change all the passwords, their OAuth tokens, and create new certificates. I mean, that's a major, well. So with one stolen key to AWS, an attacker was able to do much damage and harm. So just imagine you're a customer, this is your identity and credential management platform, and they tell you, okay, you have to change everything because we lost a key and your data. So this can be very critical. And there's one that I can remember, maybe you read that. I think that was a company from the Netherlands. They suffered it was an angry sysadmin, as far as I remember, and he was fired from the company, and he just erased everything, right? Servers, data, backups, everything. And this company actually went out of business because they lost the trust with their customers. They moved elsewhere, and once you lose the trust, it's nearly impossible to regain it. So these are just a couple of examples of data breaches and how, let's say, how massive they can be and how they can actually affect your business in a big way. So your first reaction to these data breaches could be, if you ask why do these data breaches happen, could be, well, you just have dumb admins and they're stupid and they can't protect the data. That's maybe in a couple of cases that might be true, but that's not the real story. I don't think so, because I think that the general concept of perimeter security is generally broken and flawed nowadays. So if it doesn't work anymore, and it has worked at some point, we have to ask the question, what has changed in the meantime? And a lot of things have actually changed. So the first thing is access control. A couple of years back, you had your offices, and you had your data center, you had your internal network, and you granted access from your office network, for example, to your data center, stuff like that. But this isn't true anymore. First of all, you have not only your employees working on your project. So we're living in a time where you bring in people, you bring in freelancers, you bring in part-time contractors. So it's not only your own staff that you need to manage security-wise, but also all the other people working on a project. And since these people need access to your data because they're working on a project and need access to a database or whatever, these are all potential inside threats. So even if it's a contractor, and again, just take the example of the angry admin. There was an employee. It was an inside attack, so to speak. So that has changed. The second one is the locations. You have remote offices, you have remote workers. So we, for example, as a company, we're located in Berlin, but we have people in Italy and in the Ukraine and in Scandinavia and at various places in Germany, in addition to the people working at the office. So we're quite a remote company. So, and of course, someone working from Italy needs to have access to our internal systems, the same way that let's say, office worker in Berlin needs. So you have to manage various locations. The devices have exploded. You have, of course, laptops, but you have smartphones, tablets, and generally the approach of bring your own device. And it's the same for us. If we bring in freelancers, for example, usually they all bring in their own device. So this device is now inside your network. It's plugged in. Do you know what's on this device? did you scan it? Do you know what this I don't know, what kind of software they have on it? It's a very critical issue. Even more critical is cloud computing. So we have cloud storage, okay, that's for sure. But we're living in an age of microservices, software as a service, platform as a service, infrastructure as a service. So I would say nearly half of the world's using maybe AWS or Azure or some kind of cloud provider. So the question is, if you're using services or if you're storing data on a cloud provider, is this part of your parameter, yes or no? And if you store data on, let's say, AWS, do you know who has access to your data? I mean, someone, because it's a managed service, right? So someone, some admin from AWS or Azure needs to have access to your machines, to your data. So if I open an account at AWS, I don't know who has access to my data. And people just, happily store their stuff there and run their stuff there. And just trusting the provider, Azure, Amazon, whatever, that they do things right, and protect your services and protect your data. Containerization is a very big topic at the moment, of course, Docker, Kubernetes, etc., where you have to deal with very dynamic infrastructures, dynamic IPs. You're firing up pods and destroying them as you need them. So traditional IP-based security is also not really working anymore. So we have a lot of decentralized systems, decentralized clusters, data is decentralized. And then on top of that all, you have Internet of Things. We have all these very tiny, small devices, each device collecting data, storing it somewhere. So big issue. So the traditional approach, like I said, is you have a parameter, which runs typically a data center where you have some services. You have locations and devices accessing data and services in the data center. And in addition to that, you have the cloud storage, software as a service, and platform as a service, for example. So if we're thinking about where we should draw the line regarding the parameter, it becomes quite difficult. So if we revisit the traditional approach, where we had an untrusted and a trusted area, so to speak, and compare that with the situation that we have right now, this is your parameter right now, right? So it includes everything, and everything is untrusted. And this is the basic or the fundamental principle of zero trusted networks. So zero trusted networks came, as far as I remember, from Google. So they published a paper a couple of years ago. The example was Beyond Corp, as far as I remember. So they came up with this idea or this paradigm because, of course, Google is also a very remote company, many people, and they had the problem of actually controlling access to their sensitive data. So they applied the zero trusted network principles internally first, and then kind of evolved that into a basic, principle or paradigm, and then published these papers. And from that point onwards, it kind of, the idea took off, and I have many companies trying to adopt these zero trusted network principles. So you can read from, I don't know, all big companies out there. Yesterday I read from an article from, I think it was GitHub, that they're moving very strict in that direction, and how they're going to implement these principles. So let's do a quick fact check. Fact is that companies do not have full control anymore. We have the explosion of the devices. We have data and services moving to the cloud, running in combination with data and services in your data center or data centers. If you have many devices collecting data, storing data, talking to each other, Internet of Things. And then you have the fact that inside attacks are ever increasing. So there was a study from IBM in 2016 that nowadays more than 60% of all attacks originate from the inside. And I would suspect that This was from 2016. Maybe we're already at 70%. I don't know. So you have and it's not only your typical, let's say, angry admin or angry employee. A lot of stuff goes on via social engineering. It's pretty, and maybe you saw some talks about that already, but it's pretty easy to gain access to some internal systems via social engineering. And now with the AI arriving, things will get more funny. Maybe you heard about this one social engineering attack, which I found very interesting. So they actually simulated the voice of a CEO, and they called one of their subsidiaries and said, well, we have a very important financial transaction to make because we have this big project, blah, blah, blah. So we need you to transfer, I don't know, $1 million to this and that bank account, which they actually did. And the money was, well, gone. So, with all this, AI, where you're able to fake, videos and voices and stuff like that, I think we're facing very interesting times. So the lines between the inside and the outside nowadays are, if there exist at all, I mean, they're blurry at best. So the actual shift in paradigm is first of all that, and that's in the word zero trusted networks, that no traffic can be trusted. So it doesn't matter where the request or the traffic originates. It doesn't matter if it's from inside your data center from one particular machine, or if it's from China or from the other part of the world. No traffic can be trusted. You cannot apply or you cannot rely on kind of IP-based security or traditional firewall approach where I have block some IPs and open or close some ports. And the same is true for users. So no user can be trusted, not even your sysadmins, because at one point they may decide to delete your data because you made them angry. So inside and outside personnel has to be treated exactly the same way. So one very important paradigm is move security to where the data lives. That means if you have a traditional approach with a firewall or a proxy, and I have some examples later on, that means you're not actually protecting your data lake or the place where the data actually lives. You move the access control before the actual systems, which is very, very dangerous. Because at some point, once someone, an insider or an outsider, has passed this access control, he basically has full access to your data, right? So that means you cannot have any unsecured services, and you need to make sure that each and every service that you run is inherently secure. You cannot have unencrypted traffic, and that again comes from the assumption that the attacker is already in your network. So if you have some part of your, let's say, network which is unsecured, it can and it will be attacked. And the interesting thing is that I talked about cloud providers before, and I have some knowledge about some bigger cloud providers, how they're doing and managing their stuff internally. You would be surprised if you have a look at the infrastructure and the architecture. So if you think that everything's encrypted, everything's end-to-end encrypted because you're at these big cloud providers, you're dead wrong. It's just not the case. So everyone's just, in Germany you would say, cooking with water. So even the big ones, you have unsecured, unencrypted parts in their big cloud infrastructure. It's there. So assume attackers are already in the network, and then apply least privilege strategies. So by default, no one should have access to any data. That should be the default, right? And then you should only provide access kind of on a case by case basis. And the last one is also very important: inspect and log all the traffic. it's not only to detect any ongoing data breach, somebody's, I don't know, sucking data from your network, but if a data breach happens, like the data breaches I showed before, you need to be able to know what kind of data you actually lost, you know, which records and what was in it, and when did the data breach happen, when did it stop, stuff like that. So logging, monitoring, auditing, that's also a very important part of this whole paradigm. So let's have a look at a couple of examples. And like I said, I will talk a little bit about Elasticsearch in my examples, but you can apply this to any other, let's say, database, data lake, big data storage. So this is a very typical example where you have unencrypted traffic inside your network. Typically, you have your load balancer or proxy, which terminates your TLS traffic. This is a scenario that we see very, very often, which means that this complete part here on the right is actually vulnerable because you have the attackers already lurking in your network. Access control outside your data storage. I already talked about that. So especially with Elasticsearch, that would be a typical setup. So people would say, okay, we have our Elasticsearch cluster running, and we have sensitive data in it. How do we control access to it? Well, we have a proxy. And let's say the proxy doesn't terminate TLS, so it's end-to-end encrypted. We implemented TLS pass-through. And we set up some access control lists or rules regarding who can access which data in Elasticsearch. Why are we able to do that? Well, it's pretty easy, because if I inspect the URL, so in that case, /mydata would be the name of the index where the data is stored. So I have it in my URL. I can say, okay, with my Nginx, I'm doing some, I don't know, LDAP authentication, for example. And now I implement some rules, and I can say, okay, user A has access to this mydata index and the data inside the index, and another user does not have access to it. The main problem with this particular example here is that at the proxy level, you actually don't really know what data the user is accessing. Why? Because in Elasticsearch and also other systems, you have things like, for example, a wildcard. So if I don't use my data, but my data minus star, again, I don't know at the proxy level which indices are behind that wildcard. It could be 1, it could be 100. I just don't know that. So I don't have any chance of implementing fine-grained access control when I'm not directly at the system where the data is stored. And especially with Elasticsearch, you have also stuff like an alias for an index. So my data might not be the actual name of the index. I have date math-based index name. You have bulk APIs where a lot of indices are affected, multi-get, multi-search. So what I want to say with this, or express with this example is, if you're not really implementing security inside the system where the data is hosted, you're probably not able to actually secure the system, because every system before that doesn't really know the internal details of your data structure, and in that case, index names. So in a clustered system, we also need to talk about inter-node traffic. So let's say you have end-to-end, or you have HTTPS implemented TLS pass-through. The request hits your node. Okay, everything's fine. Everything's encrypted on the left side. But the question is, what about this traffic here that's traveling between your nodes? So in every clustered or distributed system, when you want to get some data, the data is probably stored on many nodes in your system. So the nodes need to talk to each other to fulfill your search request. So in that case, again, since I know that already, I might have attackers already on the network, they could also decide to access the internode traffic and just sniff the traffic there. So I mean, it's it's probably a binary protocol, but you can reverse engineer it. You can gain access to the clear text data. And this is some objection we hear quite often. And the objection is always, well, if I use TLS to secure my traffic inside my cluster, I would lose some performance. And the answer is yes, of course, you will lose some performance. But is it worth sacrificing the integrity of your data just because of performance considerations? And again, if you go back to the examples of the data breaches, you see that if a data breach happens, that can get really costly, and that can actually destroy an entire business. And the problem when talking with customers, we sometimes face is that the customers they don't want to pay for security regarding money, regarding performance, regarding resources and people, because they don't realize that, well, yes, it costs money, it costs some performance, but it will be even costlier and maybe deadly if something happens. And that's the main problem. It gets costly only when the damage is already done. And that's why, in my experience, it's sometimes really hard to convince people that they need to secure all the traffic, even if that means they need to buy some additional hardware. They will lose a couple of % of performance. But these attacks also happened in the wild, right? So it's not something that I just made up. If this traffic is unencrypted, you can sniff it, you can tamper with it, and you can steal it. So last one, I think this is my favorite. And this is actually how the OneLogin breach happened. They didn't say whether it was Elasticsearch, whether it was a MongoDB, whether it was, I don't know, MySQL with master-slave replication, but it works in any case. So let's say you have your cluster and everything's secured. You have a 3-node cluster. What an attacker can actually do is, if they have access to some parts of your network, they can just spin up another node, let this node join your cluster. This node gets data replicated to it, and since it's under the control of your attacker, they have gained or access to your data. And this is true for every system that uses some kind of replication or data distribution, and that's exactly what happened with OneLogin. They didn't manage to get hold of the main systems, but what they could do is they could spin up another node. And like I said, it isn't mentioned if it's MySQL or what system it was, but it doesn't matter. They spun up another node and they got data replicated to it, and of course then they had control over it. So the audit logging monitoring example. So the question here is, let's say we did everything that we could, and again a data breach happened. So now we need to be able to tell exactly what data has been accessed and what data has been stolen. Who was it? At least, I don't know from which IP. For how long did this data breach last? Not only to, I don't know, give a statement to your customers, but if you take GDPR, for example, into consideration, it's explicitly mentioned what you have to do in case of a data breach. And if you're not able to fulfill these requirements, it can be really, really, really costly. So the question is, if something happens, how do you know the details? And if you don't have any, some call it audit logging, some call it monitoring, so the terms differ here a little bit. If you don't have anything in place and you're not able to actually determine what was going on, it could get costly and it can get also embarrassing. So, and the last one, it's the same example, but the question is, if you're not applying a least privileges strategy, then it also will be very, very hard to determine which user is able to access what data. So, what are approaches that we can use and leverage? Like I said, this is not a specific technology that you can just put inside your data center and then you have zero trusted network implemented. No, it's more of a, let's say, approach or paradigm, and kind of a new way of thinking about security inside your network. So the first thing that you should do is you should identify the protect surface, and this is mainly summarized under critical data, assets, applications, and services, DAAS. So in my example before, this could be an Elasticsearch cluster, a MongoDB, some microservice, whatever. The second thing to do is to map the actual transaction flows, and this is the interdependency between your surfaces, like the DAS infrastructure service and users. So you need to identify which, basically it's very easy, which system is talking to what other system, which user needs to have access to what system, and yeah, how is your data flowing from system to system. And this includes cloud, of course, as well. Like I said before, if we say everything's our parameter, or inside our parameter, that means the cloud services and cloud storage have to be taken into consideration as well. Then, well, yeah, build a zero trust architecture. This is mainly move the access controls as close to the protect surface as possible. So avoid approaches like putting a proxy, putting a firewall, and then controlling access to your systems outside these systems. Try to move it as close to the system as possible. This is then called a micro parameter. And of course, create a zero trust policy, which means that by default, no user should be given any access to any data. This should be the default. And the last one, of course, monitor and maintain. So be able to detect data breaches, of course, and monitor what's going on in your network and make sure that you can access this information afterwards. So in the last couple of, I don't know, weeks or months, I saw the term microparameter very often. And this directly refers to move controls as close to protect surface as possible. So if we say the parameter security model doesn't work anymore, so how can we kind of define the boundaries between our systems? And that's where the microparameter term comes into play. Means that every device and every data source is in fact a separate parameter. That means this was the model that we had before. So we had a couple of systems which are living inside one parameter. And microparameter basically means that each and every system has its own boundary. And this boundary is now your microparameter, and you need to look at each and every system and determine or think about how to protect this individual system with this microparameter. This is all good in theory. In practice, it poses a lot of challenges to companies. Like I said, it's a concept. It's not a blueprint, or it's not a step-by-step instruction. And if you're talking about zero-trusted networks, the implementation will be different from company to company to company because infrastructures are inherently different. There's also no really agreed upon general definition what it exactly is. There are some concepts, there are some thoughts, there are some approaches, but if you ask 10 people what zero-trusted networks means to them, you will get 10 different answers. So it's more about a paradigm shift or a new way of thinking than following some cookbook and ticking some boxes. It's not a single technical solution. There are vendors out there that will promise you, okay, so if you just use our services, our appliances, our services, then you have zero-trusted network implemented. This is simply not true. This is marketing, yada yada, and it doesn't hold any water in practice. So there's a lot of manual work and a lot of thinking, critical thinking involved in it. It's And it's not only a matter of technology. It's not only a matter of implementing firewalls and rules and doing just purely technical stuff. Processes matter as well. So I talked about least privileges approach a lot, which means give no one per default any access. So this is the default, but then the question is, okay, but people need to work with data. So what is our process of controlling who gets access to what parameter, microparameter, at what time, for how long, and why? And the why is pretty important here, because if someone says, okay, I need access to these and that data, of course the first question should always be why. So by default, no one should have access to any data, but there must be a process in place for granting data. Also regarding monitoring, for example, you need to have some processes in place. How to store your audit logs, who has access to your audit logs, how to analyze audit logs in case of a data breach. So these are all process-related questions, which means that, well, at least at the moment, many people would probably agree that implementing a zero-trusted network approach is costly. Why is it costly? Well, I talked about these microparameters, and you need to have a look at each of these microparameter and determine, okay, what access control can I implement on this microparameter? So it's much more work than just having, one firewall and then leave all the other systems inside your parameter alone because it's safe. But like I said, if you think about it, on the other hand, if you have actually, or if you suffer from a data breach, this can be costly. So if you compare the costs of implementing a zero-trusted network approach with a potential cost of a data breach, they're just different. Can add a couple of zeros to the second one. So coming back to Elasticsearch, because that's what we do mainly, when we kind of thought about how to secure an Elasticsearch cluster with a zero-trusted approach in mind. I'd like to talk a little bit about the kind of solutions or implementation details that we've come up with. So on your right-hand side, you have your data lake, in that case, Elasticsearch, and you need to have access from some location, from some device. So I think that's a no-brainer. So the first thing that we implemented was TLS everywhere. So on the REST layer, but also inside the Elasticsearch cluster. So you can do, of course, TLS protects you from data sniffing and tampering with your data, but you can add hostname verification as well, DNS lookups. You can use it for TLS client authentication, and more importantly, by using TLS also for the inter-cluster traffic, we can make sure that only trusted nodes are able to join your cluster. So in order to join your cluster, you need to have a valid, we call it TLS node certificate, which would eliminate the attack scenario where someone would just add another node to your cluster. So the whole security concept of SearchGuard is based heavily on TLS. Then, of course, role-based access control. And again, when you first install SearchGuard, what we don't have is any, let's say, default user or default role. So we don't have an admin user, we don't have a super user. If you install it, then the first thing that happens is you don't have access to your data anymore, because we do the least privileges approach. So by default, there are no roles, there are no users, and no privileges. Now, okay, how can you actually set up some roles? Because now it's quite unusable if no one has access to your data. So the idea that we came up with, again, is based on TLS. So we have a TLS, we call it TLS admin certificate. This is a TLS client certificate, which you can configure in Elasticsearch and give it admin privileges. And by using this admin certificate, you can actually set up your users and your roles. Now, the thing is that this admin client certificate has to be generated by the customer. It's not generated by us. We don't ship, some default certificate. So the admin access to the system is under full control of the customer. Then, of course, we have the document level, field level security. So fine-grained access control to your data in Elasticsearch. And SearchGuard is implemented as a plugin to Elasticsearch, which means that we can apply the security measures directly on your cluster. It's not some system that's running before Elasticsearch, it's running inside Elasticsearch, which makes it possible to determine exactly which data in which index is being accessed by which user, which documents are returned by a query, which fields are returned by a query, stuff like that. So since we're hooking into Elasticsearch request flow, we're able to actually do that. And then, of course, monitor everything. So you can track, if you so wish, you can track everything that's going on in your cluster. You can track, of course, stuff like failed login attempts, or if someone tries to spoof a TLS certificate. But if you so wish, you can also track successful searches. You can track which user has executed what search. You can track what documents this particular user accessed. You can also track what fields a particular user has accessed. So you get a complete audit trail of everything that's going on in your cluster. Now you might say, okay, but if I have a cluster that's heavily under load, where do I store that information? That's probably a topic for a different talk. Of course, you need to store it somewhere. But at least you can generate this audit trail. So we have encryption, end-to-end encryption. That's the first one. We're able to control who's able to join your cluster. We have a role-based access control with a least privileges approach. Means we don't ship any roles by default. Instead, we use a TLS client certificate. We can control access to your data from cluster all the way down to the individual field level, and we can generate complete audit log information of everything that's going on in your cluster. So that's our zero trusted network approach for this particular product. Like I said, this talk is not about pure Elasticsearch. Like I said, this can be applied to any other technology as well. MongoDB, Kafka, Redis, you name it. But that would be an example how we tried to do that inside our product. So if there are only two things for you to take away from this talk, then I would like it to be trust no one, and the second one, assume that the attacker is already in your network. Thanks very much. So I guess we have some minutes for any questions, if there are any.
Yeah, I see one guy here in the front. Please speak into the microphone.
Yes, hello. Thanks for the great talk. I have one point to add and one question. The question first. Or is there a plan in this concept how to micromanage all these policies? Because then I need a policy manager.
That's a very good question. So there's no single product that I know of to manage the policies for, let's say, all these micro parameters. That's a big challenge at the moment. So there are people kind of working on that, but as far as I know, no ready-made product at the moment. So it is a lot of manual work, a lot of documentation that you need to do. That's why I said it's costly, and it also involves processes. So I don't know of any product that would give you that out of the box at the moment.
Okay, then my point to add. When you do automation like Puppet or Ansible, protect the server, because we had an internal audit at another company, and the first thing the internal attacker was owning the Puppet server and then deploying a root user on all servers. Yeah. So that's also a parameter you have to check. The automation has to be secure by any cost.
That's a good point, and maybe I would like to add one more. I didn't talk about encryption at rest. So a lot of people, if they have data on a cloud, let's say on an S3 bucket or somewhere, it's in many cases the data is not encrypted, so it's just sitting there in plain text. And that's where I always wonder, okay, if I have my sensitive data there sitting in plain text, and I have some administrator from Azure, from AWS, which needs to have access to this machine for, I don't know, maintenance or whatever, then this person, you know, has also access to my data. And I mean, call me paranoid, maybe that didn't happen, but you know, if someone has access to your data, the potential is there that the data can get lost or can be stolen.
Okay, any other question? Well, okay.
Yeah, hello.
Hi.
When you audit the data, the search result from a customer or a user, do you record them at the moment when they get the search result?
Yes, you can do that, yeah. So what you can do is you can configure SearchCat in a way that you say, let's say you have PII data stored in a system, including first name, last name, email, that falls under GDPR. So you can say, I want to have an audit trail of all users that access this particular PII data in my index. And then we would generate an audit trail saying that user A did a search which looked like that, this and that, and the search engine returned these and that documents with this particular PII fields in it. So it's really the auditing the actual search result as well. Yeah, you can do that.
Thank you.
Okay. Oh, no, it's like an auction. Don't raise your hand. Okay, I guess. Thank you, Jochen, for your horror stories 1 week after Halloween.
Thanks very much.